Welcome back, mathematicians. In this video, we are going to determine algebraically whether these functions are even, odd, or potentially neither. As a quick reminder, in order for a function to be even, that means f of negative x is equal to f of x. If that's true, the function is even. For a function to be odd, it means that f of negative x is equal to negative f of x. And so again, if that's true, the function is considered odd. So for each instance, we need to find f of negative x. But first, let's do a quick exercise to make sure that we know how to find negative f of x and what this looks like. So negative f of x means negative 1 times the function f of x, which our function f of x is equal to x to the fourth plus 2x squared plus 9. Let's now distribute that negative, and so what we get is negative x to the fourth minus 2x squared minus 9. So now we have a model for what it should be if it's f of x, what it should be if it's negative f of x. So now our goal is to find f of negative x. F of negative x means I'm going to write the function, but I'm going to replace the variable x with the expression negative x. When I do this, I write parentheses, and again, I'm replacing that x with negative x everywhere in my function. I'm now going to simplify, and negative x raised to the fourth power, well, a negative raised to the fourth power will always result in a positive product. And x to the fourth power is x to the fourth. So the result of this, negative x raised to the fourth power, is x to the fourth power. Then we have 2 times the quantity negative x squared, and negative x quantity squared one more time, since it's an even power, it's going to be a negative times a negative, and then we have x to the second power, so the result is x squared. And then finally we have 2 times x squared, which is 2x squared. So now we can see that f of negative x is equal to x to the fourth power plus 2x squared plus 9, which is equal to the original function. Because of that, we can say that the function is even. You may also notice that since this is a polynomial function and all powers are even, we will get an even function. Now to our second problem where we have a rational function. We're going to again start by finding negative g of x, just because it's helpful to have this function so that way we can compare g of negative x to either the original function g of x or the opposite, which is negative g of x. This means I'm going to take negative 1 times that ratio of x over x squared plus 2. As a reminder, what I'm really doing is I'm taking negative 1 over 1 and I'm multiplying two fractions, which means I'm multiplying across. I will get a product of negative x in the numerator and x squared plus 2 in the denominator. Now I'm going to go ahead and find g of negative x. This means I'm going to replace the variable x with the expression negative x. So I have negative x in the numerator and negative x quantity squared plus 2 in the denominator. Well, negative x in the numerator doesn't change, so we have g of negative x is equal to just negative x in the numerator, and then negative x quantity squared is positive x squared, as we saw in the last problem, and we drop down the plus 2. So this does not match the original function x over x squared plus 2, but it does match the opposite, so negative g of x. And because it does match the opposite, this function is considered odd. All right, guys, good luck.